Okay, this is the additional video for lagrange method and finding the maximum minimum value in partial derivative. So if you see these questions, you can pause the video and try to solve it and state which following options is true. Okay, now the solutions for this case is if it is asking from the function of two variables, the first thing we can do is we need to find the partial x and partial y, right? Okay, now we start from partial x. We can derive partial x. We derive and we can write and partial y. And then these two partials we can equal to 0. Okay, now from these equations we can have some solutions. So we can solve this for x is equal y. So we can say that this is our equations that we need to solve. Then we are going to have x is 3x plus 2. So x is 0 and x is equal to negative 2 over 3. Okay, so we have from this equations we have several points. So first we have 0, 0, so critical points. 0, 0 and negative 2 over 3, negative 2 over 3. So we have 2 points. So this is wrong. This one is wrong. Okay, now we check the determinant. So partial x, partial y minus partial xy squared, right? Okay, now we can take this into our solution from here. Partial x will be 6x. Partial y will be negative 2. Partial xy will be 0. Sorry, not 0. Partial xy will be 2. Okay, now we can write here that 4, 0, 0, t will equal to 0 minus 2 squared. So this will be negative 4. So meaning 0, 0 is saddle point. And negative 2 over 3, negative 2 over 3, we check the d. This is negative 12 over 3, negative 4, negative 4, and then negative 2, and then negative 2 squared. So 8 minus 4 is 4. Oh, sorry. Negative 4, negative xy, yeah, negative 4, negative 2, 8 minus 4. Oh yeah, it's 4, it's correct. So d is positive. So when we check partial x is 6 multiplied with negative 2 over 3 is negative 4. So it's less than 0. So we have the local maximum. So negative 2 over 3 is a local maximum. So we have this is wrong, this is wrong, this is a saddle point. I think we already got directly answer from here. Okay, that's how we solve this type of question. Okay, next question that I prepare for this video. Okay, again, similar questions. Okay, we have a function of two variables, and you need to select which one of the statements that is true. You can pause the video and have your own way to solve this, and we can check later with my solutions. Okay, now we can start to write down the partial derivative for each functions. So we will have minus x cubed plus 2x squared plus 4x. Sorry, plus 4y should be equal to 0, and then partial y will be 4x minus 2y. She should be equal to 0. Okay, now we have y equal to 2x. Then we can start to solve and substitute this into here. So we can start to write minus x cubed plus 2x squared plus 8x equals 0. So we'll have x minus x squared plus 2x plus 8. Okay, so x or let me write negative x to make it more clear. So x equals 0, and then this will be factorized. X minus 4, x plus 2. So x equal 4, and then x equal negative 2. So we have 0, 0. We have 4, 8, and we have negative 2, negative 4. Okay, we have 3 critical points. So of course, it's not 4, but it's 3. And then we can start to check the second derivative. So second derivative, we can write partial x, x. And partial y, y is negative 2. And the partial x, y is 4. Okay, and then we can start to write, maybe make a table. So make a table for 0, 0. We have d. D will be 0 minus 4 squared. So this will be in a negative. This will be a saddle point. Is there any? Okay. So we check another one. 4, 8. We check 4. We check 4. 4 squared is 16. Negative 48 plus 16 is negative 32. Negative 32 multiple negative 2 is 64 minus 16. Should be positive, right? Should be positive. So this is positive. And then we can try the let me write the partial x is a negative. The partial x is negative. Okay, so this will be a local maximum, local max. And then another point we can check. D will be negative 2 squared for negative 12, negative 8, so negative 20, negative 2, 40 minus 16 is already positive. And I check the partial xx, check the partial xx, it's a negative, another negative, it's similar, right? So we'll have another local max. So we have two local max. Okay, so two local max. So no local minimum. So we have two local maximum. So it's C. Okay. Now last question. This is about the still maximum minimum, but it is having a constraint. So if you have a constraint, then probably one method that you can try. Okay, you can pause the video and try by yourself. Okay, we can start with if you have any constraint. So you have a value that you want to maximize or minimize. You have a set of constraint functions. Then this is a problem for Lagrange method. Okay. Now first we let the function as x squared plus y squared. Okay, and we have the constraint as function g. So we can write this. Okay. Now the first thing to know that in the Lagrange, the idea is we need to make a equation in balance for each gradient vector. So gradient vectors for f should be equal to gradient vector of g with some factors that it multiply with g. Okay. Now this part we have because it's two variable, so we will have partial x and partial y. So 2x and 2y, and this is lambda, and then 2x minus 2 and 2y. y minus 4. Okay. Now we can take this into our equations. That is 2x is equal lambda 2x minus 2 and 2y lambda 2y minus 4. Now we solve this. And this is becoming x one minus lambda is equal to, or let me write lambda minus 1 is equal to lambda. Okay. And the second one we have the same but different multiplication of lambda. Okay. So if we look here, okay, if you look here, we can see that it has same or it's a multiplications twice the lambda, right? So we can write that the x, since it's 2 lambda, since it's 2 lambda, okay, so the 4 lambda is twice of the x, okay? So we can write down that this 2 lambda, if we multiply this by 2, so 2x lambda, and this is 4 lambda, this will be, we can write down the equations as y lambda minus 1. Okay, so we can write that we might have, okay, if lambda, so the possibility here is from this lambda minus 1, we can have lambda minus 1 equals 0 or lambda minus 1 not equal 0. Okay. So what's happening with if we have lambda equal 1, which means that we have a 0 in lambda minus 1. Then 2x should be equal to 2x minus 2. Okay. So it doesn't feel correct, right? So we see the second opinion for this one, and that is, I think, quite true. So if we have lambda minus 1 not equal 0, then we can simplify this into this equations. Okay. And now if we let our constraint, that is this equations, okay, so our constraint is x squared minus 2x plus y squared minus 4y. So let's exchange all the y into x. Okay, so we can write down it becomes like that, and this is equal to 0, right? So we can say that this is 5x squared minus 10x equals 0. And we might have 5x minus 10. So x equals 0 and 5x equals 10 or x equal 2. So when we have two critical points, 0, 0 and 2, 4. So check back to the equations. We will see that the only way that it can be maximized is using the f(2,4), and if we check to the equations, so this will be 4 minus 4, 0, so plus 2x, it's 4 squared is 16 minus 4, sorry, why I'm writing here, not checking to here, checking to the to here, sorry, checking to this optimized x squared plus y squared. So x squared plus y squared, so this will be 4 plus 16 equal 20. Okay, so the 20 will be the maximum value for this function, so 20 will be the answer. It's B. Okay. Now another thing that we can imagine from this, okay, we can have another alternatives for the solution. So if we know that our function is x squared plus y squared, this is practically the distance, right? The distance squared from origin, right, to some point xy, right? Okay, now if we look on more clear way for g is this one, right? So if we try to complete the square, we would have, this will be plus 1, this will be plus 4, right? So we will have plus 1 plus 5 is 5, okay? So this will be x minus 1 squared plus y minus 2 squared 5. So this is a circle equations. Okay, so circle equations centered at x equal 1, y equal 2, or 1, 2, like that. So which means and also the radius is square root of 5. Okay, so the maxima of x squared plus y squared is the distance, okay, the distance between 0, 0 to 1, 2. Okay, this is for the x. Plus square root of 5 and then squared. So this will be 4 plus 1 squared is square root of 5. So we will have 2 square root of 5 squared, and it's also 20. So you can also look on the geometrical property for this question as well. Okay, sometimes you can check the geometric value, geometric shape or property. You can also observe and solve according to geometry. Okay, so that's, I think, the additional video for maximum minimum value and Lagrange method. Okay.